In this video, we are going to see one more problem on Thevenin's theorem. What is the question given? Determine the current through 2 ohms resistor connected between A and B. So he asked to find the current through A and B, which is flowing through 2 ohms resistor. So he asked the current through A and B are 2 ohms in the circuit using Thevenin's theorem. Before solving this problem, you should know the importance of Thevenin's theorem and statement of Thevenin's theorem. I will provide that video in iCards and a link in the description. First go and watch that video and come to this video. So from Thevenin's theorem, the first step is calculate VTH, nothing but VThevenin's. By eliminating this 2 ohms resistor between A and B, we should draw the circuit. Then the circuit look as follows. Here I am using mesh analysis. For mesh analysis, I am considering loop equations. So current flowing through this loop is I1 and current flowing through this loop is I2. So I am using mesh analysis. At loop 1, which is 14 ohms into I1 minus 12 I2, which is equal here I1 touching first negative terminal of 2 volts, which is minus 2 equal to 0. 14 I1 minus 12 I2, which is equals to 2. Consider this as equation number 1. And from loop 2, if we write equations, 1 plus 3 4, 4 plus 2 is 16, 16 I2 minus 12 I1. Here I2 touching first positive terminal of 4 volts, so plus 4, which is equals to 0. Now if we rewrite this equation, it's equals to minus 4. Consider this as equation 2. Solving 1 and 2, we get I1 and I2. Here I1 equal to minus 1 by 5 amps, I2 equals to minus 2 by 5 amps. Now let us take this point as node 1 and voltage at that point is V1. Now if you write nodal equation here, now finding V1 here, if we use this equation, V2 minus V1 by 2, which is equals to I1, taking along through current direction. So 2 minus V1 by 2, which is equals to I1 minus 1 by 5, which is minus 1 by 5, minus 2 minus V1, which is equals to minus 1 by 5 into 2. I am writing top. So take and go minus 1 to this side and minus 2 by 5 to this side. We get V1 is equals to 2 plus 2 by 5, 5 to the 10, 10 plus 2 12, which is 12 by 5. V1 equal to, here I am taking along with current direction. Here V1 minus VA by 1 ohms is equals to I2. I2 is equals to minus 2 by 5. Take and go 1 to this side, which is not effect. Here V1 is equals to 12 by 5 minus VA. Take and go minus VA to this side and plus 2 by 5 to other side. So VA is equals to 12 by 5 plus 2 by 5. Now VA is equals to 14 by 5. Again here VB, we want to calculate VB. I am using this equation along with the current direction. So I2 VB minus V1 by 12 ohms. To find VB, we are taking VB minus V1. Here I2 is along or taking direction and I1 is coming opposite the direction of this. So minus I1 here, VB minus what is V1? V1 we get as 12 by 5 by 12, which is equals to I2 minus 2 by 5, and I1 minus of minus plus 1 by 5 here, minus 1 by 5, taken come 12 to this side, so here 12 by 5, which is VB. Here taken go minus 12 to other side, so positive 12 by 15. So minus plus going to cancel, VB is equals to 0. Therefore VTH is equals to VA minus VB. Here we got VA as equals to 14 by 5, VB is equals to 0. Hence VTH is equals to, again in second step of Thevenin's theorem we need to calculate RTH. So calculating RTH, which is R equivalent without the load resistance. So we need to calculate RTH by removing load resistance between A and B, and replacing these sources with their internal resistance. If we replace with this internal resistance, then voltage source is short circuited. So voltage source is short circuited. Then the equivalent circuit look like this. Here we should follow the direction like this in solving the equivalent circuit. Here 2 and 12 are in parallel, so this equivalent is, so the equivalent circuit look like this. Again this 1 ohm and this 12 by 7 is are in series. Then we are going to get 19 by 7 in, if we redraw this, we are going to get A, B, again these two are in parallel. Then between A and B we obtained equivalent resistances, and B we obtained equivalent resistance as 57 by 40 ohms. So RTH is equals to 57 by 40 ohms. Again the last step of Thevenin's theorem is draw Thevenin's equivalent circuit. Then what is Thevenin equivalent circuit? The Thevenin's equivalent circuit look like this, which is RL, RTH and VTH. From calculation we obtained VTH is equals to 14 by 5 volts, and RTH we obtained is equals to 57 by 40 ohms. Then RL is given as between A and B, RL is given as 2 ohms. So he asked to find current through AB, or current flowing through 2 ohms resistor. Then what is current flowing through 2 ohms resistor? I am taking loop current as I. So 57 by 40 plus 2 into I, which is equals to 14 by 5. How I write this equation? I write this equation in form of IR is equals to V. So now I is equals to 14 by 5 into 1 by 57 by 40 plus 2. If we put this value as it is in calci, then we are going to get I is equals to 0.8175 amps, which is approximation of 0.82 amps. So current through this IBR 2 ohms is 0.82 amperes. So such a way here we are, so here we will get I is equals to 0.82 amps. In such a way we are going to solve Thevenin's theorem. If you like this video, don't forget to subscribe my channel.